Hey, happy Star Wars Day. And I would like to introduce you to our rabbit. And his name is Rocky. And you might have seen him early on in the videos. And Rocky's here to help show me how strong the Force is with me. And so we're going to use the Force, a little magic. And you're going to have to help me to make a rabbit appear on top of your head. I bet you don't believe I can do that, but I can. And so I'm going to make a rabbit appear on top of your head. So you got to help me because my Force might not be strong. I'm not quite the Jedi Master yet. Okay? And so we're going to make a rabbit appear on your head. And you still doubt, but you'll see in a second. Okay? So we're going to maybe need some magic words. Maybe we should say, abracadabra. Did it work? Take your hand, put it on top of your head. Do you feel a rabbit? Not quite yet? Okay, we got to try better. We got to really use the Force. Okay. Abracadabra, alakazam! Yes! I see it! It's on your head! Put your hand up there. Do you feel a little hair? Hair, rabbit, huh? Did you feel a little hair? And in these days, since they don't let us go to the barber, you probably feel a lot more than a little hair. You probably feel a lot of hair. And right here, this guy is a lot of hair. Rocky, say hi to him today. Happy Star Wars Day. Yeah. So we'll let Rocky go back to whatever he does. And we'll get on to do some e-learning. So I'm glad you're here on this Monday. Okay. And it's a Monday, so that means get the attendance taken right away. And that also means we have new logic problems. I'm very proud of the number of people that did logic problems last week. And so it's just like old times. And so, except we don't have grade trackers, no quizzes, no tests, no grade trackers, and no more notebook scores for the end of the year. But you need to make sure that we got warm-ups on Khan Academy, and we have logic problems every week. And so you need to get them done. And get those turned in. And so the logic problems, whether warm-ups, logic, geometry, algebra, pre-algebra, all have the same logic this week. Your warm-ups are already there, 3 new ones that will tie in with what we're doing. And so we want to give you some logic problem hints for this first one. And so here we are. Whoa, kind of big. And so the first problem, you are going to make a path of 77 numbers. And you're going to go horizontal and vertical, and you're going to number them. And the first part of the path is 1, and the last part's 77, and you're going to go horizontal and vertical. You're not going to go diagonal. And we could call it a snake. We've done ones like this before. And the numbers on the outside tell you how many in that column are in the snake. So there's 3 here, and there's 3 here, but there's only 1 here. Okay? And so when we look at this, we're going to start making the path. Well, if there's 3 in this column, these 3 have to be part of the snake. And so it's in the snake, if you look up here, it does not lay next to itself. It won't be right there, so you won't have 2 rows or 2 columns of numbers filled in next to each other, and even diagonally. But so what we're going to do is start numbering these. So the snake starts here and it goes 1, 2, 3, 4. Well, the snake's going to have to go here for 5. There are 3 used in this column. So it can't turn down because then it would touch itself and already lay against the snake. So it has to go up. So this is 6. Well, it has to turn. This is 7. Well, this is a 1. So that means all of these are not used. And then that means this is an 8. Okay? Well, there's 6 used. Now that doesn't mean all 6 are in order. It could go down, over, and then come back. Well, it might not do that because there's a 1 here. That means it's only going to cross this once. This 12 does not mean they're 12 in a row. It's just 12 total. Okay? So I have a few other hints, like this 0 means these aren't going to be used. And this 4 means all 4 of these are going to be used. A 1 means when you cross the path, you don't cross back. And so those 1s are huge hints. And so when we get here, there's a 3. 3 of these are going to be used. When we go across here, 3 of these, you're not going to use this one. This is just trying to trick you because it's a trap, like Admiral Akbar on Star Wars always said. And so that little thing, that's a trap. This one, you can't go down in there and get out, so that's a trap. And so several things, and you got to find your path, not diagonal, horizontal and vertical, to end up at 77 right here. And so make sure you can get that, okay? So that's going to be worth quite a few points. So make sure you kind of keep track of where the empty ones are and keep track of where the path for the snake is, okay? And then we got one more type of question here at the bottom we want to show you. Part is all just letter codes, and we've done ones like this before. This problem, there's 9 letters, and we're going to use the numbers 1 to 9. This problem is 5 letters. We're going to use the numbers 1 to 5. This problem down here, even across my face, is 16 letters, and so we're going to use the numbers 1 to 16. But let's give you some hints on these. We'll do this one together. If I'm using the numbers 1 to 5, you could write those out and cross them off if you wanted. And if cab adds up to 11, and B adds up to 7, and Abe adds up to 8, different letters in this problem. The last one we did while we were still at school, I remember those days, we actually had different letters use the same number when we had all our names. And there's several that had a value of 1. But this one, different letters are different numbers because we're using them 1 to 5, 1 to 9, 1 to 16. So when I write out 1 to 5, the only way to get an 11 is 4, 5, and 2. So that means 4, 5, and 2 for cab. Well, that means in B, the E has to be 1 or 3. Well, it could be 1, 1, 5. Or it could be 3, 3, 1. Well, which one is it? Preston? Yeah, because cab has 2, 4, and 5, and B is in cab, so B can't be the 1, so B has to be the 5. Well, if B's the 5, then E's 1. Well, if B's 5 and E's 1, down here, that would 5 plus 1 is 6, that'd make A 2. Well, if A is 2, 2 plus 5 is 7, that'd make C 4. Is that an explosive? Ooh, we shouldn't be talking about that. And so C4, and then D wasn't even in any of the words. Well, D, that's what's left over. And so it'd be 1, 2, 3, 4, 5. And so we did that one together. Now here you're using the numbers 1 to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now I got some hints. If you multiply any number times 2, it's going to be even. You multiply any number times 2, it's going to be even. That means D is even because 14 is even. G doubled is an even. So an even plus a what is an even? Well, that means A is even. E doubled, that's an I, but the letter's E. Oh, it's a trap, it's a trap. And so E doubled is an even. And an even plus an even. So Y is an even. These might not be even because you're doubling them. This doubled plus this doubled is an even. That means V is an even. And so there's some hints there on your even numbers. I think I pretty much told you all the even numbers. And then this last one, which is going to be the hardest, we want to give you one hint here because we just love to give you hints. And what you want to do is you're like, what are some of these words? Hassan, Salah, I don't know this. But look, this and this both have an H. They both have 2 A's. What's the only difference between those, Rosie? Yes, the N and the L. And so this one has an N, and so if you subtract all the things they have in common, the only thing that's different is the N and the L. And how much bigger, Rosie, is the N than the L? They're 15. The N is 15 more than the L. Well, if I'm using the numbers 1 to 16, then what would be that number? Bree? Yes! L has to be 1, and N has to be 16. And that is your hint from the Jedi Master. So all you Padawan learners, those are your hints on your logic problems. Make sure you get them done. I know some of you are like, I'm going to get them done Monday. I'm going to show Mr. Nyson. Just like old times, I'll have them done before the end of the day. And so I'm excited. And so we keep them to a front side. Just try to get them all in and send them in. And now let's figure out what we're going to do for the notes and the homework. Algebra today. But before we do that, some of you might be wondering, who was playing the violin on those Star Wars songs? Well, that was our oldest daughter, Anna, and she's home. Well, they came home early from college, but she would have graduated this past Saturday. And so we had a cake for her on Sunday, and she put her graduation cap and gown on. They haven't had graduation, but they're planning on maybe having it in August. But she has played the violin all through high school and all through college, and so she does a great job with that, and so she's also graduating, so we try to celebrate that. And she's planning on heading off to the University of Indianapolis for graduate school for physical therapy. So good job, Anna, and thanks for helping out with playing the violin on the video today. And so that was her, in case you were wondering. And some of you might have met her. I know some of you have. And so, but for algebra today, it's so strange because we finished up with those work problems. And normally we would take a day and review everything and then take another day and test you. But that's not happening in this situation. No tests, so we're not reviewing. And we're going to go straight on to the next topic. Well, the next topic that we still have to finish, there's two more. One is inequalities. And then after that, we got to do quadratic equations and functions. And then we got to do trigonometry, but still before the end of the year. And so we're moving on to the inequalities. We're skipping quite a few sections. We're going to hit the highlights. And so tonight's homework is assignment 121, page 480, 5 to 37 odd. Yes, they're all odd. And those of you that might just write answers, don't do it because the answers in the back of the book are not the way I want you to write them anyways. So that isn't going to help you out. And so we're going to talk about what we want you to do. But when we talk about inequalities today, we're going to skip. Notice this is section 10.4. That means we're skipping 10.1, 10.2, 10.3. We did all that stuff in pre-algebra. And so we can go straight to 10.4 and talk about combined inequalities. Well, there's two types of, when you combine inequalities, you can talk about conjunctions. Conjunction, junction, what's your function? That's a different type of conjunction. But conjunctions, and they're used similarly in algebra. So that's C-O-N-J-U-N-C-T-I-O-N. There's conjunctions and there's disjunctions. Big words and kind of hard to write with a mouse. So there's conjunctions and disjunctions. So on our notes today, we're going to compare and contrast this. And some of you noticed that last Friday I called that assignment 121, and really it's 121 today. Some of you caught that. So if you know I goof up on a major thing, you can email me. But most of you got it. That's just, oh, Mr. Nyson miswrote it. So he's trying to think about too many things. So when you do a conjunction, you have two inequalities. That's going to be the word and. Now in grammar, a conjunction is and, or, but, nor. And both of these things are conjunctions in English. But in math, the conjunction or is really a disjunction. And so and is the conjunction, or is the disjunction. And means both inequalities must be true. Both must be true. In a disjunction, only at least one must be true. That's an L. Doesn't look like an L. Come on. Get that? And so at least one inequality must be true. And so if we look at this, I want x is greater than -2 and x is less than 3. I want all numbers that are greater than -2 and less than 3. Now, here's the frantic pre-algebra review. Are these closed dots or open dots? So on your warm-ups this week, I assigned that on Khan Academy. Closed dots or open dots. So if you're having trouble with that, maybe you should do that first. And so, but when there's nothing underneath the alligator mouth, are those closed or open? What would it be, Ilya? Yes, they're open dots. And so you put an open dot at -2, and you put an open dot at 3. Well, we would do the same thing over here. We would put an open dot at 2, and we would put an open dot at -3. Where am I going to be? I guess I would be at the head of this paper up here. And so we're going to put an open dot at -2 and an open dot at 3. Well, the thing is, if x, all numbers greater than -2, that would be here going this way. And if I want all numbers less than 3, that would be here going this way. Well, if both have to be true, it's this section in the middle. And so this is all we're going to graph. We're only going to graph this. On a number line, you're going to put an open dot and an open dot, and we're going to give you some little mnemonic devices, some little ways to remember, and we're going to say, and graphs land, like an island. It's all together in the middle between the two dots. In an or, we're going to graph gore. It's going to have a hole in the middle. Woo! But that doesn't work on this one, because if I'm going greater than -2, and then I'm going less than 3, normally it would graph an or because these wouldn't overlap. This would be over here, and there'd be a hole in the middle, but you can't see me pointing at it. See, it's right there. There'd be a hole in the middle. And so ors would graph gore. But this one overlaps. And since it overlaps and we could be in either one, well, that means we could be in this one. Well, I need to change colors. That means we could be in this one going to the right, or we could be in this one going to the left, but when you are in either one, it's really the whole line. And that's not going to happen on your homework to the very end. And then we will say the answer is all real numbers. Everything works. Okay? So we're going to have some more examples of that. And we'll show you what the examples on the notes are going to look like. Okay? So let's take a look at the next part of the notes. And let's look at these next two examples. Again, I did the same problems just twice, so you can compare and contrast them. But that doesn't happen in your homework. You just get one of each. So, also on your warm-ups, reviewing pre-algebra, when you solve an inequality, remember it's the same as solving an equation, except when you multiply or divide both sides by a negative, you must do what, Jacob? Yes, flip the sign. Do, 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 do. Sign flipping initiated. And you must flip the sign if you divide or multiply both sides by a negative. So, when I divide both sides by a negative, I get R. And then Elizabeth, a positive divided by a negative is a negative. Great job. Instead of R is greater than -3, we're going to flip it. And R is less than -3. And at the same time, if we solve this, we're going to subtract 12. And these are steps you're going to show on your homework. And you're going to get 3R is greater than or equal to -12. And then we divide by 3. Colin, should I be flipping the sign on this? Just because I got -4, do we flip the sign, Colin? Yes? No! You didn't divide both sides by a negative. We divided both sides by a positive, so you don't flip the sign. So my answer is this. R is less than -3 and R is greater or equal to -4. And your back of the book writes it out in words. Oh, that's awful. But we are just going to plot on a number line. Now your number line, if I put 0 here, where's -3 and -4? -1, -2, -3. Negative numbers go to the left. So don't be plotting number lines backwards, or we'll have number line remediation. And so this is an open dot at -3. This is a closed dot at -4. But since it's an and, notice this says R is less than -3. R is greater than or equal to -4. If you have to be in both, you're in this section right here. And see, that graphs land. And graphs land. Here, we would say or graphs agor, but we have our -4, and we have our -3, and we still have our answers. It's just R is, since I already solved it, I'm not resolving it. R is less than -3, or R is greater or equal to -4. Well, that includes everything. Because if you're greater than or equal to -4, you're going this way. And if you're less than 3, you can't even tell it's open because it's already over or closed. So your answer, ooh, that was bad, is just the whole thing with arrows. And so that's the whole thing. Now, we're not going to talk, all these things in school we talk about. Interval notation would mean this is all real numbers. Interval notation here, you don't have to do this on your homework. We'll just write this down. Is you put the two endpoints, and we will talk about this later, and you use a parenthesis for an open dot, and you use a bracket for a closed dot. And that's called set notation. And so set notation here, the left side would be -infinity, which you never get to, so that's an open dot. And the right side would be +infinity, and that'd get you to there. So that's interval notation for that, okay? You don't have to worry about interval notation. All we're going to do is graph number lines, but I throw it in so you get an extra 2 cents worth, okay? So let's take a look at the very last example. On to these very last ones. Ooh, I got to erase, okay? And so on this one, these are going to be called, you can call them chained inequalities, sometimes people do, where they're all linked together. And chained inequalities are always an and. They are always a conjunction. And they should always graph land and island. And so an and is a conjunction. C-O-N-J-U-N-C-T-I-O-N. And so that'd be that. So let's write this. 3 more than twice the number is less than 17, but it's at least -1. So 3 more than twice the number is less than 17, and it's greater than or equal to -1. Well, see how these are chained together? You got 2 inequality signs, and it's all chained together. Well, the thing is, you got 2 of them. You got this problem right here that you could solve, and then you could write an and. And then you have this, well, I want a different color. Give me a different color. And so then you have this one that's right here. So you could rewrite it twice and say -1 less than or equal to 3 plus 2x, and 3 plus 2x is less than 17. And that's really what's going on. Well, you're going to subtract 3 from both of these, and you would get -4 is less than or equal to 2x, and 2x is less than 14, because you subtract 3 from both sides, and then you divide by 2. So instead of showing all this work twice, which gets kind of irritating, because you'd get -2 is less than or equal to x, and then here you get x is less than 7. And it's an and. And so if I had 0 here, and I had 1, a 2, a 3, a 4, a 5, a 6, a 7, and then I had -1, -2, and if I was going to graph this, what would be a closed dot or open dot? What do we have? Dominic? Closed dot -2, and then Abigail, open dot at 7, and then and is between. So and graphs land. The interval notation that you don't have to worry about is you just put the endpoints of your line. -2's at that end, 7's at this end, parenthesis here because it's an open dot, and bracket here because it's a closed dot. But you don't have to do that in your homework. But many of you are going to go, Mr. Nyson, can't I just go -3 to each of these parts? And notice -1 minus 3 is my -4. When you subtract 3 here, it's just 2x, and you subtract 3 here, you get a 14. And then you could just divide everything by 2, like I did, and then you would just get x less than 7 greater than or equal to -2. Now what you want to make sure is the smaller number, when you write it this way, should always be on the left. And the bigger number should always be on the right, not the bigger number on the left and the smaller number on the right. We go from least to greatest, okay? This last example, and see if we could do the shortcut on it. Let's see. Oh, let's get the sound off my face. Like, oh, there you go. And so let's see if we could do the shortcut on this. And so if I subtract 2 from each side, that would work because you have like 3 sections. You have this section, you have this section, you have this section. So if I first subtract 2, I could do that. But see, I don't really want to do that. I want to subtract 2. This is my middle section, so I could change this to plus -3. And I'd want to subtract 5 from each section because usually the letter's in the middle. And so if we subtract that, 2 minus 5 is -3 plus x is greater than -3x, which is greater than 3. But the problem is, I have x in 2 sections. I have it in this section and I have it in this section. And so if I like subtract x from each section, I'll still have it in 2 sections. And so this isn't going to work. So when you have a chained inequality and you got 3 sections, you got the letter in 2 of them, you have to break it apart. There's no way of getting around it. You have to write -3 plus x is greater than -3x. And since it's chained, you write and then we're going to do this one right here. -3x is greater than 3. And then we can solve these. Well, this one we divide by -3. Toot, 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 toot. We are dividing both sides by a negative. If you divide both sides by a negative, you must reverse the sign. And so we get x is less than -1. And that solves that part. And here, if we subtract x from both sides, we will get -3 is greater than -4x. And then how are we going to solve this, Cam? Yeah, divide both sides by -4. And then Judah, what do we get? We get +3/4 because a negative divided by a negative is a positive. And so we have x is less than 3/4. And some of you are going to think, well, this word and doesn't mean anything. Yeah, it does. Because if I'm here, here's 0, here's 1, here's -1. 3/4 is halfway between the halfway and 1. And you're like, well, let's graph. Ooh, I forgot to flip the sign here. Oh, no. That could be trouble. If you divide both sides by a negative, Judah, yes, flip the sign. So x is greater than 3/4. So if we're greater than 3/4 and we're less than -1, you could say, well, that's fine. That's the answer. You're either here or you're here. But see, it's not an or. It's an and. We can't be here or here. So since and doesn't graph land, this is a no solution. And if that happens on your homework, you just have an empty number line. You don't actually graph anything on it. Your homework tonight is all odd, but reading in the back of the book is not what we want. We want you to graph all your answers. That's what it says underneath me. And so we're going to graph them. We're going to give you some homework hints. Not as many as last Friday, but we're going to get you some. So here they are. What we have to do. And so on your homework, don't do the oral exercises. Make sure you do the written. And so we're on page 580. It's 4 to 37 odd. It's assignment 121. And so we're starting at problem 5. So you're going to write problem 5 on your own paper. Okay, it's going to be right here. And so underneath this, let's try something new. Woo. If I don't want to hit the top one. So like if this is problem 5, you could copy the problem down. And then you could on the next line write -1, -1, -1. You can do that to all 3. And so you'd have -2 is less than a, which is less than 2. Well, that's a conjunction. It's a chained inequality. It's going to be an and. And so when you get your number line, let me get a number line here. When I get a number line going here, oh, you can't. Ha! It's hidden by the white blob. But if we take that number line, we take this number line right here, we want you to graph the answer. So you put 0 here. You could go by 2's. You don't have to. There's 2. There's -2. Are these open dots or closed dots? What would they be? Logan? Yes, open dots. And a chain inequality is an and. And so we just color in between. Okay? So that's what we're going to do. If it's an or, like if we look at 15 here, you just solve them each individually. This one, you subtract 1, and you get 2x is greater than or equal to 2. And then you divide by 2, so x is greater than or equal to 1. The pen's still kind of thick there. This one, you subtract 1, and you get 2x is less than or equal to -4. And then you divide by 2. You don't flip the sign because you're not divided by a negative. And so this is an or. So if we were going to graph x is greater than 1, greater than or equal to 1, or x is less than -2, on a number line, using your straight edge, you have 0, 1, -1, -2. And if I am doing greater than or equal to 1, Aiden, yes, that's a closed dot, and then greater than's this way. Then here, x is less than -2. Jack, that'd be open dot, and we go this way. And see, notice how or graphs out gore. There's a hole in the middle. Okay? And so we want to see number lines on your homework. Okay? And so you can look the answers up in the back of the book, but we want to see number lines on your homework. And the one that we're going to do with you on the last part is like problem 19. Divide everything by -1. And when you do that, you're flipping all the signs. So this is going to be really 6. I said we normally do not put the bigger number on the left. So you'd flip the whole thing. And so it'd be 6 is greater than or equal to x, which is greater than or equal to -2. And you would circle this, bigger number on the right side. And on a number line, you'd have a closed dot at 6. You'd have a closed dot at -2. And a chain inequality, less than and makes land. Last one, problem 35 that I'm going to give you a hint on. This one has a letter in all 3 sections. So what you have to do is you write that down and you solve it. Add c to both sides, subtract 3, and you get it. Then it's an and. So it's a chained inequality. And then you write and you solve this one. Subtract c from both sides, subtract 3. And if it makes an and, it better graph land. Okay? And the same thing here is solve this one. You can either divide by 2 or distribute the 2. But this is an or, so only at least one of them has to be true. And then you solve this one. Okay? And those are the last 2, and they're the hardest, and they're in the C section. Okay? So make sure, working hard. If you have any questions on any of them or don't understand some of them, just let me know. But these little words are very important. And so they tell you or and. Okay? So make sure, email me, let me know where you're at. And so we miss all you guys. We wish we could all be together and it'd be a lot easier. And so, but keep working hard. You're doing a great job. And I know some of you will probably get your logic problems done today and you'll send them to me and say, see, I got them. And so, but thank you. And hey, we look forward to hearing from you. So email your assignments and questions. Bye-bye.